All right, so parent function quiz review session. Uh, I know we've talked about it quite a bit in class already as far as what to expect on this quiz. Again, first one of the year, we want to make sure that we're getting off on the right foot. Make sure that we're, again, positive things going into that grade book, I suppose, I guess is what I'm trying to say. So again, everything within reason, of course, but most everything that we've discussed to this point has been reviewed to some degree. Again, there have been a few new things sprinkled in, specifically the interval notation. But again, if you know and understand what's going on in this podcasted review session, you're going to be in very good shape on Monday's quiz. So, absolutely need to make sure that we know and understand where or what's happening. So in this review session, understand please that I'm going to be shaking it up a little bit. Again, here, as you can see, I've got like in number one, I've got a sketch drawn up there. It's going to be our job to determine what sketch this is. Again, it's made pretty clear that's parabola. Again, this is going to be our quadratic function, and the equation that goes along with, we'd have to say that f of x is equal to, in this case, it would be x squared. I think, like I said, talked about this in each of the classes. This is not exactly what your quiz is going to look like. Instead, you're going to be given this part. You'll need to come up with this. You'll need to come up with the sketch of the graph. But when you sketch that graph, make sure that key point's in the correct spot. I would say that you would need at least, bare minimum, at least 3 additional points. I would encourage you to have as many accurate points as you could. So in number 2, when we look up here, that V shape, this is going to be the absolute value function. Absolute value function, exactly that. We have f of x is equal to the absolute value of x. And again, just so say that we're here, I know that some people seem to be a little concerned with domain and range. Again, we will see some domain and range on the quiz, but not necessarily on the front side like this. But hey, a little bit of practice never hurts. Back to the quadratic, the domain, as we could see, looking at the x terms, again, there are no x restrictions, or no restrictions, I should say, in place of x. So we can move from negative to positive infinity. The range, though, cannot be negative. So the lowest value that we start with is at 0, extending, I should say, all the way to infinity. Pretty much the exact same story on this side over here with the absolute value, the domain. Again, no restrictions. You put anything you want in place for x. Again, positive, negative, 0. But the range, you're just going to be very, very unsuccessful if you're trying to get back to the negative value. Again, we're going to go from 0 and extend all the way to. Let's see. Next, we have again, very clearly, we have the a linear function. But specifically because it's going through the origin with the slope of 1, we call that the identity function. And f of x in this case is simply just going to be x. So if we want to come up with the domain, again, no restrictions at all. So the domain, again, is going to be from negative to positive infinity. The range in this case, again, negative to positive infinity. Values back out. Number 4 is we take a look at that. This looks like the square root function. Square root function is going to be that f of x is equal to the square root of x. The domain here, again, now all of a sudden we do have a restriction. We're not allowed to put a negative value in place for x because it has the square root of a negative and stay in the real number system. So we could have go as low as 0, but from 0 we're going to extend through positive infinity. Range, same exact story. 0 is the smallest output, but we could extend through. Number 5, as we continue to move right along here, this is going to be our cubic function. Cubic function always increasing through the origin. Cubic function is going to be f of x is equal to x cubed. The domain, as we've said now a couple of other times, is going to be extending from negative infinity to infinity. The range also would be extending from negative infinity to infinity. Next up, we have the constant function. In constant, we have that horizontal line. That's the giveaway. The way that we would write that up is that, in this case, particular time to this specific example, that's f of x equals 2. We could have also talked about just in general terms, f of x is equal to c for constant. But again, I like seeing that this is, I can actually read it better, say that f of x is equal to 2, because that's the graph that we have presented to us in number 6. The domain in this case, again, all real numbers, you put anything you want in place for x, it's not going to change anything. And there's nowhere to literally replace the x. The range, on the other hand, again, in this case, 2 is the only output that you're ever going to obtain. So it's not saying from 2 to something else. It's just 2. That's it. Again, next up, this is going to be our greatest integer function. Again, the greatest integer function. The way that we write that up, f of x is equal to, again, greatest integer of x, something like that. Again, not incredibly easy to see, but we want you to understand we have closed points on the left, open points on the right. Again, that didn't make it any more clear. So close on the left, open on the right. So again, at the origin, close on the left, open on the right, close on the left, open on the right, close on the left, open on the right. So just so you're very, very clear in terms of that. Here again, we would say, I should correct it. The domain is, again, even though we're jumping all over, from -5 to infinity. The range, this was the weird one, where we would say, basically spell it out. So we would say all integer values, from from -infinity to infinity. So as long as you're an integer, you can be anything from -5 to infinity. You'll be able to see this next graph. Again, this next graph, this is going to be what we refer to as the reciprocal function. Again, the reciprocal function, this is where we tie in with the fraction, again, 1 over x. As far as the domain is concerned, this one gets a little strange as well. We can put anything we want in place for x except for 0. So as long as we're going from -infinity to 0, 0 cannot be included. We're going to pick right back up 0 going to positive infinity. Again, literally everything except for 0 is acceptable. Same story with the range. We are going to go from -infinity to 0. We're going to pick right back up and go from 0 to infinity. But we have to showcase that 0 doesn't work. It's not going to go in terms for my x value or my f of x value. So that's what we have to do. All right, so those are your parent functions. Again, all 8 of them. And the only other stuff that we need to be prepared for on this quiz is going to be essentially, this is now, I'm talking now like the backside of the quiz. It's going to be kind of a put together of what we did in class today mixed with bits and pieces of what we've done in past views. So number 9 says that we want to determine the parent function. Again, shorthand there, PF, the parent function. We want to figure the graph and then state the domain of the range. So we can see here, g of x is equal to negative quantity x plus 3 cubed minus 1. So hopefully what we're feeling pretty good about is recognizing the parent function, again, because of that cube 3 up there, x1 over 3. This is going to be the cubic function. We want to describe the transformation. So as soon as I see this negative out front, I know that that's not part of the cubing that's happening. That's happening separately, so I know that's going to be affecting vertically. So we're going to say this is a reflection over the x-axis. So we're going to reflect, again, over the x-axis. I also know that, again, when looking at that plus 3 within the parentheses, that means that the horizontal, I'm going to move to the left 3 units, and that minus 1 that's happening outside of the parentheses, that indicates that I'm going to be moving down 1 unit. So we have to understand that how do I want to say this? The sketch or the graph that I'm going to be reflecting over the x and moving left 3 and down 1 is the parent function. So again, it's going to be beneficial for us to know what this parent function is going to look like. Let's see, 2 up 8, 2 down 8. But again, trying to sketch this with the dotted line, and it looks somewhat natural. That's what our parent function is going to look like. So like I said, we've got to reflect this over the x-axis. So when I reflect it over the x-axis, again, very roughly sketched in, looking something like that now, reflecting over the x-axis. And then now I'm going to be moving down 3, or I'm sorry, left 3, down 1. So what I've just sketched here in green, again, now this is what we're going to be reflecting and moving. So the reflection has already taken place, but now we need to move that, again, left 3, down 1. As we talked about in class, we do not want to think about moving all infinite number of points at the same time. Instead, we're going to move this key point. Whoa. There. We're going to try to move this key point, that critical point. So if I were to move that key point left 3, down 1, I'm going to move left 1, 2, 3, down 1, and that's now where that key point is going to lid. As we can see, again, the integrity of the graph has not changed, meaning we haven't stretched it or shrunk it vertically, horizontal, anything like that. So from the origin, now instead of going right one, up one, I'm going to go left one, up one, right one, down one. Let's see, left 2, up 8, 2, 3, 4, 5, 6, 7, 8. Right 2, down 8. It's going to end up here. And now, got a lot of extra stuff going on here. I'm going to erase that intermediate step with green. I'm going to leave the parent function as we asked that you do. But what I've got in blue now, that's going to be my sketch. All right? So now, when we're asked to identify the domain of the range, it is not of the parent function. Again, it is not of f of x equals x cubed. Again, we want the domain of the range of g of x. So, in looking, the domain in the range of g of x is going to be, it looks like the domain is going to be going from negative infinity to infinity. Because again, no restrictions on the x. The range also is going to be going from negative infinity to infinity. So here we actually would have gotten away with it had we accidentally identified domain and range of the parent function, because it would have worked out the exact same. But let's not play that game, I suppose. All right, number 10, taking a look at this one, we want to determine the parent function. We want to sketch the graph, state the domain and the range. So as I'm noticing that there's an x in the denominator, that's going to tell that this is going to be a reciprocal function. So we're going to write this up here before I forget. So the reciprocal function, excuse me, reciprocal function is going to look something very roughly like this. Again, in terms of my parent function, something along these lines. Like I said, this is what our parent roughly is going to look like. But we know that by description that we're going to be adjusting. So when I look at that -2 that's occurring inside the parentheses, that tells us that we're going to be moving to the right 2 units. When I see this +3 that's happening outside of the function, away from the function, that tells us that we're going to be moving up 3. So I would still argue that the key point on this graph is still the origin, because we can clearly see how my 2 asymptotes, I have a horizontal and a vertical asymptote at our axes. That's where they're converging. That's what's happening. So I still think that's going to be the easiest point for us to actually move. So it appears that I'm going to be moving that origin point right 2 up 3, and this is where that's going to be located. So we need to think of it this way, that if the graph, the entire graph is moved right 2 up 3, that the asymptotes are actually going to be moved as well. So the horizontal asymptote is going to be moved up 3. The vertical asymptote is going to be moved right 2. Now, hopefully, we're still able to essentially keep track of what's actually happening here. But hopefully we're recognizing that, again, down 1 over 1, up 1 over 1, that this in green is where my actual graph is going to be located. Again, I apologize that I'm kind of making a mess out of this. Normally we don't sketch in the asymptotes for this exact reason, but I still think that it's going to be beneficial for us to see. So keeping the actual graph intact, but movement is going to be necessary. So when it comes time for us to look at the domain, like I said, domain, basically we're talking about that vertical asymptote. Vertical asymptote seems to be happening at where x equals 2, which means x is not allowed to equal 2. So we're going to identify that the domain is from negative infinity to 2. We're going to pick right back up and go from 2 to infinity. For the range, our only restriction that we have in place now is where the horizontal asymptote is located at positive 3. So we're going to say that our range is going to extend from negative infinity to 3, pick right back up and go from 3 to infinity. So this is the review session. This is, like I said, if you could follow along and do exactly what I was doing along with me over these last 14, 15 minutes, you're going to be perfectly fine on Monday's quiz. What I would ask that you do in the top left corner, just so I know that you watched, go ahead and write the word math and put a heart around it, because I know you all love math so much. Again, we're talking something like this in the top left corner of your quiz. That'll be a little indication that I can see that, hey, you actually watched this thing. So study hard, good luck, and we'll see you on Monday.